Welcome to the Muxall Open IoT channel. I am your host, Michael Crane.
Okay, so I'm getting a little bit lazy in my old age, and I didn't really feel like breaking out the big camera for this because I kind of wanted to make it quick, but I wanted to show you guys what was going on. So if you're wondering what this device is here, this is the Muxall anemometer. And it measures air pressure, kind of air speed / pressure type thing, more of an air pressure thing, I guess. And there is a V3 Muxall Pro BBQ Controller, and right there is the GUI, or the web app, sorry. I know, people don't like it when I call it a GUI. Anyway, you can see right there, oh, that's the fan override, but right above it is the fan speed. So, yeah, told you guys I've been working on it. Go ahead and fire this guy up. And as you can see, it pretty much brought this thing all the way to the top. See the fan running there. And this is not a very technical or accurate type test. It just gave me a starting point. The cylinder right here is tapered just a little bit, and it was made out of a drinking straw holder that I found in the kitchen. And of course, everyone recognizes the white box. That's what the controller comes shipped in. And of course, the barbecue fan, right? So, yeah. Oh, here's the controller. In case you're wondering, this is a V3 controller. It's not a V4. And I thought I'd use that. But yeah, I have this would work on a V4 as well. Like I keep telling everyone, they're pretty much identical. Anyway, so yeah, so let's look at the fan speed. I'll try to do this where I can point at the same time. Okay, so we'll just hit 40%. And there you go. Now, so that actually looks pretty good. I'm surprised it looks so close. Like I said, this isn't a very technical video or technical test. It just kind of gave me a starting point. I had to tinker with different frequencies and duty cycle, on time mixed with frequency. Anyway, I might do a video on it if other people are interested. Yeah, so we got a 40% there. And you can hear it kind of pulsing. That's the electronics in the controller. I think I can pulse up to run a PCM of about 50 milliseconds on, 50 milliseconds off. The problem is when you do that at that fast, it smooths out the fan so you don't get the boop, 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 boop. But it also greatly reduces the amount of power that's being delivered, and the fan barely runs. So this is running about at a frequency of about 7 hertz, and I'm pulse. I don't remember the exact pulse width of it. I can post it later. Maybe I'll post it when I post a video on the different settings. But anyway, so yeah, I'll show you a couple more here. I guess I'll show you all of them. So we'll go to 10. And as you can see, it pretty much dropped all the way to the bottom. It kind of will float a little bit. Anyway, like I said, it's not a very technical test. I didn't want to go any lower than this, and this percentage is based on kind of this setup right here. So yeah, you can kind of see it kind of popping up there. We'll do the 20%. I guess we'll just go up the ladder here. As you can see, 20% is kind of jumping around. Now, you're probably wondering, like, thinking, wow, that's pretty high. But, I mean, yeah, it's jumping up and down. But you have to remember this tube's tapered, so it takes more air the higher it gets. Anyway, that's kind of my explanation of it. Yeah, see this oscillation? This was hard to find a good pulse width and frequency, so we didn't get a bunch of this oscillation, because in my mind that's going to cause problems. You're not going to get a constant airflow, right? So I was trying to find the right combination with the fan that wouldn't cause too much pulsing of the air. All right, let's go back down here, and I think we already saw 40. We'll do it again real quick. So anyway, that's 40. All right. Oh, let me back up a little bit so you can get to see the whole thing. And let's see, we'll do 60. Oops. There you go. Yeah, and I know you're thinking, yeah, 20, 40, and 60 all look pretty close, but it's because, like I said, the taper. 80 is going to be a little bit better. And this might need some tweaking. We'll have to do some testing on it. Oop. There's 80. Now 80's blowing it all the way up to the top. Yeah, this is a real high-tech thing here. This thing gets kind of jammed too. There we go. It gets kind of stuck up in here. Anyway, it's close. And 100 is it's pretty much just nailed to the top. Yeah, and if this was calibrated a little better, 100 would be, just barely at the top. 80 would be around here. 50, 40. Kind of get the idea. But like I said, this will give us a starting point. One of the things I want to do, this is actually a question. So this is on the control page, and you can kind of just set the fan to run at whatever speed while you're cooking. Or I was thinking about giving the user the ability to change the fan speed for different profiles. So if you're doing something at 180, you can change the fan speed to change the fan speed to like 60%. But if you're cooking at 350, then you can hit it back on 100%, so it'll heat up better. You know what I mean? Okay. And another thing, this doesn't work yet. This will be where it'll tell you what the fan speed is, so you kind of know. So anyway, that's about it for this video. I just wanted to show you guys what was going on and maybe get some comments. I'll talk to you guys later.
Don't forget, you can support the Muxall Open IoT channel by donation using a credit card and PayPal, or by purchasing products at the Muxall store. Details and links are in the description under this video. Well, that's it for this video. If you liked the video, give it a big thumbs up, that helps, and hit the subscribe button, that really helps. If you have any questions or comments, post them in the comments under this video. Thanks for watching, and I'll see you next time.